We can find a stationary point by taking the derivative of the function and setting it to 0. However, we can determine the nature of our stationary points by looking at points either side of them. Now, just looking at the function that we've got here, we can see that the two stationary points that will occur here and down here are different, mainly because the graph is different on either side of these functions. Looking at this point down here, we can see on a graph that it is at a low point in it. What we would do is we'll call this a minimum stationary point. However, we can't always just look at a graph. So what we need to do is being able to determine the nature of a stationary point via maths. And the way that we do this is by putting all of the information into a table. So we draw up just something small that looks like this, and we start putting in some information. At the beginning, we're going to put in our known stationary point, so that's when our derivative of our x point is going to be equal to 0. Now we need to have a look at either side of the graph and sort of see what's happening with the graph. So we're going to look at the derivative at a point higher than our x value, which I'm just going to add by a plus h here. And for a minimum, as you can see on the graph, it raises. So that means that our graph goes up and that we end up with a positive derivative. And we do the same thing on the other side. So we take a point that's slightly less than our original value, which I'm just denoting as a minus h in this situation. And that can be along this part of the graph. And then what we're looking at is the derivative to be negative and it to slope downwards. Now we've found the nature of this stationary point mathematically, we can find the nature of this stationary point mathematically as well. Now, as you can see, it raises on one side and lowers on the other, so we call this a maximum point. And to find its nature, we do the similar thing. We've added in our graph, and we're going to put in our stationary point. So our f prime of x is 0. Now we need to have a look at, again, a point on the positive side of this, so f prime of x1 plus a small value, and this part needs to go down, so it needs a negative derivative. On the other side, we need a point that's less than our stationary point, so our f prime of x minus a value should be traveling positively. So our derivative is positive. Now we've had a look at the two stationary points that are on this graph. However, there is a third type of stationary point, and that's called an inflection point. Now let's see what's different about those. Again, as always, we're writing in our original stationary point, and that's going to be equal to 0. And we're going to, again, look at 2 points either side of it. So our f of x1 plus h, and our f of x1 minus h. So we've seen that a maximum and a minimum have a gradient either side that are opposite. An inflection point has the derivative the same on either side of the point. So we can have a positive and a positive, and a negative and a negative. So these are our 3 types of stationary points: a maximum, a minimum, and our inflection points.